Hi guys, today's our second day of starting Sigma notation. Today is just kind of to build off of what we did last class. So we talked about the lower bounds, the upper bounds, and then our rules that we plug those into. Today we're just going to be looking at some different rules that we're going to be applying that to. More specifically, the first one we're going to be talking about today is absolute value rule. So we're going to do example number 1 together on here. And you can just watch the video, fill in the notes as we go. So we remember from last class that our lower bound is x equals 1. That's the lowest number we're going to be plugging into our rule. And then the upper bound is on top of our sigma, and that's the number 4. So that's all the way down here on my last line that they gave me. And then in the middle, between 1 and 4, I just want to think about the numbers in between my lower bound 1 and my upper bound 4. So x equals 1. After that comes x equals 2, and then we have x equals 3, and finally x equals 4. And again, there'll always be the amount of lines that you need to plug in your given bounds and numbers in between those bounds into your rule. So now we go to look at our rule, and this time we said our rule is absolute value. So we have to remember a couple things about absolute value. No matter what, with absolute value, it always makes my answer positive because it's really just the distance from 0, and distance is always a positive thing. So I'm going to start by taking our rule and, again, just kind of mapping it out. Wherever I see an x, I'm going to leave a parenthesis because that's where I want to plug in the given number. So I wrote out my rule without the x, and we know that we're just plugging in whatever our x equals. So in this case, because my lower bound is 1, I plug in the number 1. Okay? Then I'm going to do the same thing for x equals 2. So I'm going to map it out, my absolute value bar, 3, parentheses, minus 10. And our second problem is x equals 2. So I'm going to plug in the number 2 into my parentheses. I always like to use parentheses just to kind of keep it clean and so that I know what comes next when I do my PEMDAS or even when I plug it into the calculator that it's clear. So my third piece is x equals 3, so I'm going to plug in the number 3. And then finally my upper bound we get to, which is x equals 4, so then I know I'm just plugging in the number 4. Okay? And then I want to treat these just like they're all totally separate problems. I don't like to get them all mushed together, so I keep them very separate. So let's start with the first one. When I think about PEMDAS, I always want to start with what's inside of my absolute value bars or inside of my parentheses. So inside of these big absolute value bars, I have 3 times 1 minus 10. So let's start here. I have the absolute value of 3 times 1, which is just 3, minus 10, absolute value. Okay, and then we can keep going. So the absolute value of 3 minus 10, well, 3 minus 10 is negative 7. But as we stated earlier, the absolute value of negative 7, absolute value bars, always make your answer positive. So positive 7. All of these steps, guys, I do want to see them on your work. It is going to take some time, but I think skipping steps are where people get messed up with these. So try and keep your steps very organized. Let's try number 2. Same thing. Let's start with the inside. 3 times 2, that's 6, minus 10. And again, that's inside of those absolute value bars. The absolute value of 6 minus 10, 6 minus 10 is just negative 4. But when I take the absolute value of negative 4, I get a positive 4. Okay. The next one, absolute value of, absolute value of 3 times 3, which is 9, minus 10. Oh man, there we go. And then we know that 9 minus 10 is the absolute value of negative 1. Absolute value of negative 1 is a positive 1. Finally, our last one, the absolute value of 3 times 4, which is 12, minus 2. Well, 12 minus 2 is just 10 inside of the absolute value bars, but Oh, I'm sorry, 3 minus 10. There we go. And then 12 minus 10 is the absolute value of 2. But when we take the absolute value of a positive number, it stays positive no matter what. Your answer from the inside of an absolute value bar will always be a positive number. Now, just like we did with our first day of sigma notation, we're not done yet until we add up all of our pieces together. So 7 plus 4 plus 1 plus 2 gives me a total of 14. And 14 here is my answer. So again, I want to make sure that you guys make it clear what your answer is in these problems. So we add them all up, we get 14. Okay? Using example number 1, I want you guys to go ahead and try example number 2, please. It's absolute value. Again, I think it's helpful to show all of your steps so that you kind of get an idea for where these numbers are coming from. If you have a question, pop on to Zoom and we can talk about it. When you're ready, guys, you can move on to example number 3 with the video. So example number 3 is our last type of rule we're going to be talking about. And it starts off the same way. So identifying our lower bound here this time is x equals negative 5. And that goes all the way up to our upper bound, which is negative 2. And remember, because we're adding, my numbers are getting smaller in this case because we're getting less negative. So we're going closer towards the positive numbers. So negative 5, if I add 1, I get x equals negative 4. If I add 1, I get x equals negative 3. And then if I add 1, I get x equals negative 2. And again, it looks kind of weird because my numbers are going technically down, but because we're negative, they're getting closer to 0. So we're adding 1. They are getting bigger. Okay. Then we're going to take each one and we're going to separately plug in our numbers. So we're going to start with our rule. The rule that they gave us this time is x plus 3, the whole thing squared. So when I plug this in, I want to be really careful with my parentheses. So let's start with this big parentheses on the outside. And we have a squared on the outside. And then I have some number, right? So that's where my x is going to go, plus 3. So I kind of have a small parentheses inside of a big parentheses. Now, that number that we're going to plug in for x, that's that lower bound. So we're going to plug in the number negative 5 in here. Okay, then let's do the same thing for negative 4. So we're going to have parentheses plus 3 all squared. And this time inside of those parentheses where x used to be, we're going to have a negative 4. Same thing. And this time x is the number negative 3. So I'm going to plug in the number negative 3. And then finally, our last one, we said x is equal to negative 2. So I'm going to plug in the number negative 2. Okay, and let's treat them all separately, just so we have the space to do the math. So let's start with our first one. When we think about PEMDAS, we always want to start with inside of the parentheses. So inside of these parentheses, I have negative 5 plus 3. And you can type that in your calculator, do it in your head. You would get negative 2. And then we want to square it. Now, when you type this into your calculator, you want to make sure these parentheses are there always before you type the squared. If you don't do that, it's going to give you a number that's negative. But we know that negative 2 times negative 2 is a positive 4. So if you do type it in the calculator, parentheses. Okay, let's do the next one. So negative 4 plus 3, that's the number negative 1. And again, those should stay inside of parentheses. Negative 1 squared, negative 1 times negative 1 is a positive 1. Next one, we have negative 3 plus 3 is just 0. And when I square the number 0, I just get 0. And finally, our last one, negative 2 plus 3 is a positive 1 squared. And 1 squared, 1 times 1 is just 1. And then our final step, we want to add up all of our pieces And when I add them all up, I get the number 6, and that is my final answer. Okay, so really the trick with these guys is just being really neat with your work, making sure that every piece you plug in, you show your work for it, show your steps, make sure you have parentheses. And again, if you have any questions, please let me know. So use this example to help you with number 4. And then when you're ready, you're going to move on to numbers 5 through 9. Use today's class notes and use the previous class notes to help you with any of these examples. And like always, if you have any questions, feel free to message me or find me on Zoom. All right, guys, thank you. Have a good day.